A small fire breathes in the dark. You can hear it. A soft, slow exhalation of resin and ember. The kind of sound that lives just under the rim of the ocean's larger sound. Salt on the air. A faint, sweet smoke. The shellfish has been done for an hour, but the warm shells are still cradled in the ash at the edge of the coals, and the flesh inside still steams. You shift your weight on the sand. The sand here is fine and pale, packed firm by the tide. Behind you, the stone wall of the shelter holds the day's warmth like a slow heart. Above you, the sky is the kind of black you have forgotten was possible. No streetlight, no screen, no window glow. Only the stars, in their immense, scattered crowds, and the great river of light that runs across them, and the faint chalk smear of cloud near the horizon. You are at a place that will one day be called Pinnacle Point. It is on the southern coast of Africa. The year, by a calendar that has not been invented yet, is somewhere around 74,000 years before the present. A small band of people sit around the fire with you. Some of them are sleeping. A child leans against an older woman's leg. A man tilts his head back and watches the sky for a long time without speaking. The Indian Ocean works at the rocks below the cave, slow and even, the same beat it has kept for 10,000 generations. The fire pops. Somewhere a bird, woken by something in the dark, makes one short note and then chooses sleep again. The fire breathes, the tide breathes. Your own breath slows to meet them, there in the dark, on the coast, where the night has weight and patience. You think those stars will be there tomorrow. They will not. You think the danger, when it comes, will arrive as a sound, a roar, a flood, a spear in the firelight, an animal at the mouth of the cave. You think the world ends loudly. It does not, this time. This time the world ends quietly, and from the other side of the planet, and the only people alive on Earth do not know it has happened for days. By the time the stars go out, the eruption will already be 3 days old. By the time the cold begins to take the dawn chorus, the magma will already be cooling into glass on a coast 9,000 kilometers away. By the time the genetic record of every human alive today is decided, no one in this band will know they were the survivors. They will only know that the night sky has gone strange and the food has begun to thin and the children are coughing more than they did in the season before. There is a story you have probably heard. It says that humanity once almost vanished. It says that we were down to a few thousand. It says we were a single bad season from gone. It blames a volcano. It calls it Toba. It tells you we got lucky. Some of that story is true. Some of it has been argued over for 30 years and is still being argued over now. The version you grew up with is not quite the version the evidence tells. The actual story is stranger and quieter, and in some ways more astonishing, because the people on this beach do not collapse. They are clever, and the ocean keeps them, and they outlast a sky that should have killed them. And every person alive today is descended from someone who sat by a fire, something like this one, and waited. So lie back, let the blanket settle, let the room around you do its small soft work. The night is long, and we have all the time we need. The night is long, and you have all the time you need. Let it start here, on a coast in Africa, before the sky changed. Let it end here, after the sky comes back. In between, the world will tear itself apart, and a small band of people you will never meet will inherit your DNA. That is the journey. Settle in. Close your eyes if you want to. The fire is steady. You are safe. The coast at Pinnacle Point sits at the southern tip of a continent that, in this season, looks almost familiar to you. There are antelope on the plains above the cliffs, and small predators in the grass, and the salt wind moves up over the rocks the way it does today. The ocean is a little colder than it will be in your century, and the shoreline is farther out, because the world's water is locked into ice in places that are not yet called Greenland or the Laurentide. You would not recognize the constellations, not exactly, but you would recognize the silence. You would recognize the smell of wood smoke caught in a person's hair. You would recognize the weight of a child's head on your thigh. There are perhaps a few thousand people on this stretch of coast. Across the whole continent, perhaps a few 100,000. The numbers are guesses, but the guesses are made by people who count tools and bones and pollen for a living, and the guesses agree, more or less. Humanity, on this night, is small, not endangered, not yet, but small. The species lives in pockets. Africa is the great hearth. There are scattered bands east into the Levant. Some have already pushed across into what will one day be India. They are doing well, those eastern bands. They are making good tools. They are eating well. They have not noticed that the world is about to change. The people in the shelter with you have a way of life that is older than they can imagine. They forage along the beach at low tide. They prize mussels and limpets off the rocks. They dig for sand-living invertebrates with a sharpened stick. They climb up to the dune fynbos to collect tubers and bulbs that store sugar through the dry season. They hunt small antelope when the antelope wander down the cliff paths. They know which plants close their leaves at dusk, and which berries are bitter only when they are unripe, and which kind of tide is best for prizing things off rock. They pass this knowledge on by doing, by showing, by stories told to half-asleep children at the lip of a fire just like the one in front of you now. They have one thing that earlier hominins did not have, or rather, they have many things, but one in particular changes everything. They use the sea. The sea is a buffer. The sea does not freeze. The sea does not stop providing protein in a bad year. When the inland antelope thin out because the grass has thinned out because the rain has thinned out, the mussels are still there, slick on the wet rocks. When the tubers fail, the limpets do not. When the world above the waterline gets harsh, the world below the waterline keeps producing. This is a quiet revolution. It will save them. They do not yet know it needs to. They also have a thing that archaeologists in your century will get very excited about. They take silkrete, a hard pale stone good for blades, and they put it under their fire. Not in the fire, exactly, under it. They pile the embers over a buried slab of stone, and they let it sit there for hours, and they wait, and the next morning they take the stone out, and the stone has changed. It is harder in some ways. It is more workable in others. It flakes the way they want it to flake. It holds an edge. They have, without writing it down, without naming it, without theorizing it, invented heat treatment of stone. They are doing something with rock and fire that no animal has ever done before. The man who watches the sky now, the one whose head tilts back, knows the names of the stars in his language. The names are gone. They were gone 3,000 generations before you were born. We do not know what he calls the Pleiades. We do not know if he calls them anything. We know only that the sky is brighter than your sky, and quieter, and more full, and that he watches it with the long, easy patience of a person who has done this every clear night since he was a child. He cannot name the constellation that will be called Sagittarius, but he knows that when those particular stars rise above the cliff in this particular way, the season is changing. He has a calendar. The calendar lives in his eyes. He is reading it now. The fire moves. The child stirs. The older woman shifts her hip on the sand and smooths the child's hair. The wind off the ocean is warm tonight. The mussels in the coals make small clicking sounds as they cool. Somewhere on the beach below, a sandpiper picks at something. The man stops watching the sky. He looks at the woman. They do not speak. They have known each other so long that they no longer need to say small things out loud. He pulls a hide closer around his shoulders. He lies down. The shelter holds its warmth. Above all of you, the river of stars keeps moving slowly, the way it always has. You can almost feel yourself begin to drift. That is the right pace for this. There is no hurry. The volcano has not happened yet. It will happen in the next paragraph, but in the lived moment of these people, it has not. They have their whole night. The sky is theirs. The coast is quiet. The stars are overhead. And somewhere, on the other side of the world, the ground has already begun to shift. Imagine a place you have probably never thought about. Northern Sumatra, a green, mountainous island in what your maps will eventually call Indonesia. The forest there is dense and steaming. Hornbills calling, macaques moving through the canopy, rivers running fast over volcanic rock. The land has been quiet for a very long time. So quiet that people, if there were any people there yet, would have walked across the dome of it without knowing what was underneath them. 20 kilometers down, deep under the floor of the forest, there is a chamber. It is the size of a small country. It has been filling for 500,000 years. Slowly, droplet by droplet, magma has pooled into it from the slow grinding of plates beneath. The chamber is not new. It has been quietly working since long before any human ancestor stood upright on 2 feet. It has been waiting for a very long time. Tonight, in the language of geology, it will not wait any longer. The pressure in such a chamber is hard to describe in human terms. It is the weight of mountains, multiplied by the weight of the rock above the mountains, multiplied by the heat of liquid stone trying to expand. The crust above it is a lid. The lid has been holding for hundreds of millennia. There are vents, here and there, where small amounts of gas escape. There are tremors, every so often, when the rock above shifts a centimeter. None of this is enough. Tonight the lid begins to fail in a single place, and once it fails in one place, it fails everywhere, because the pressure does not negotiate. It simply finds the path that opens first, and goes through it, and widens it as it goes. What happens next is the largest geological event in 2 million years. The number is hard to hold in your mind. Try, anyway. 5,300 cubic kilometers of magma blasts out of the ground in a single afternoon. To picture that volume, picture a cube. Each side of the cube is roughly 17 kilometers long. That cube of liquid rock and pulverized crust is shot upward into the sky. The eruption column climbs 40 kilometers into the air. It punches into the stratosphere. It pierces the ceiling of weather. The ash and gas and shattered crust spread sideways at the top, like a great anvil, and begin to drift outward on the winds at altitudes where airliners, in your century, would not yet be able to fly. You would not have heard it from where you were sitting on the African coast. The sound of an explosion that large is funny. It does not actually carry around the world. Sound waves bend in the atmosphere, and they are absorbed by oceans, and they fade, and by the time they had reached the southern tip of Africa, they would have been less than a whisper. The man with the hides over his shoulders would not have woken. The child sleeping against the older woman would not have stirred. The fire would not have wavered. The ocean would not have noticed. The eruption that was about to remake the climate of the entire planet was, in the moment it happened, completely silent for almost everyone who would feel it. For things closer to Sumatra, of course, it was not silent. It was the loudest thing that has happened on this planet in the long memory of geology. Anything within hundreds of kilometers of the vent died in the first hour. Pyroclastic flows came too. Those are dense rivers of superheated gas and ash, hot enough to scorch stone, fast enough that nothing alive in their path survived. They moved outward across the island. The forests that had been quiet that morning were no longer there by evening. The hornbills, the macaques, the rivers, the trees that had taken 1,000 years to grow, all of it was simply gone, replaced by a smoking blanket of grey, hundreds of meters deep in places. But there were no humans there, not yet. The pre-modern hominins who would, much later, pass through that part of the world were still elsewhere. Whatever Toba killed, in that first afternoon, it killed before our line had reached. We owe a great deal, as a species, to the geography of our slowness. If our ancestors had moved 1,000 kilometers faster out of Africa, the eruption would have caught them in its first breath. They had not. So they survived the explosion by simply being far away. The explosion would find them anyway, in time, but it would find them on its own slow terms. In the immediate aftermath, the volcano collapsed. The roof of the magma chamber, no longer supported by what was inside it, simply fell. A bowl appeared in the surface of the world, 100 kilometers long and 30 wide. You can still see it. It is a lake now. In your century, people take boats across it. They photograph the shoreline. There are villages on its rim. The water is calm and warm and full of fish. None of that calm is in any way connected to what made the bowl. The bowl was made by the ground falling into itself. So that is what happened. Now, the slow part begins. The eruption ends in a matter of days. The climate does not. The climate is what kills. And somewhere far from the volcano, breathing slowly in the dark, your ancestors do not yet know that the world above them is going quiet, that the long cold has already begun its patient work on the air they share. For the next several days, ash falls. It falls heavily near the volcano. It falls less heavily, but still measurably, almost everywhere. In a place that will one day be the Jwalapuram River Valley in southern India, the ash drifts down for days like grey snow. By the time it stops, it lies thick on the forest floor. People are there. We will come back to them. They will live through this. For now, they are coughing, and the children are coughing more than the adults, and the water in the rivers is the color of old milk. In Africa, much further away, the ash arrives almost invisibly. There is no grey snow on the southern coast. There is, instead, a kind of dimness in the sky. A high, thin haze, the color of old bone. You would not necessarily have noticed it in the first day. You might have thought it was a strange sea fog. By the second day, you would have noticed. By the third, you would have known something was wrong, but you would not have known what, because the cause was 9,000 kilometers away, and your culture had no concept of a place that far. What is happening, scientifically, is this. The eruption did not just throw out rock, it threw out gas. Vast quantities of sulfur dioxide, perhaps 2,000 million tons of it, were injected into the stratosphere. The stratosphere is the layer of atmosphere where weather does not reach. Things that get into the stratosphere stay there, suspended, for years. The sulfur dioxide reacts with water vapor. It becomes droplets of sulfuric acid. The droplets are tiny, but there are unimaginable numbers of them, and together they form a global haze. They drift on the high-altitude winds. Within weeks, they are everywhere. They are above your fire on the African coast. They are above the ash-covered valley in India. They are above the steaming wreck of what used to be northern Sumatra. They are above places that have no people at all. They make a sheet, a veil, a thin grey mirror. That mirror does what mirrors do. It reflects sunlight back into space. The sun does not set. Exactly. It just gets dimmer. Each morning, when the African sky should be turning that particular pale blue, it turns a kind of weak, dull grey instead. The dawn does not feel like dawn. The colours of the world are less saturated. You look at the sea and you think the sea is the wrong colour, and you do not know why. The man who watches the sky tilts his head back and frowns. The stars at night are still there, behind the haze, but he has to look harder for them. The pattern he uses to read the season is still there, but it is fainter, and the brightness of the small stars is gone. He is uneasy. He does not say so. He sleeps less. Within weeks, the temperature begins to drop. It does not drop all at once. The ocean is enormous, and the ocean stores heat. The continents are surrounded by ocean, and the ocean buffers them. So in the first month, the change is subtle. A morning is a little colder than expected. The wind off the water is a little harsher. The sand stays a little damper through the day. The mussels are still there. The fire is still warm. The shelter still holds, but the band notices. They notice in the way bodies notice. The older people pull their hides closer. The children sleep a little nearer the fire. The dogs that are not yet dogs but are something almost like dogs lie tighter against the children, and the children do not push them away. By the end of the first year, the cold is no longer subtle. The plants on the cliffs above the shelter, the ones that should be flowering in the warm months, do not flower. Or they flower late and badly, and the bees who visit them are fewer, and the seed they make is small. The antelope come down to the beach more often, looking for forage they cannot find on the plains. There are more antelope in some weeks, fewer in others. The whole rhythm of the year is wrong. In the high latitudes of the northern hemisphere, the change is brutal. The interior of the continent that will one day be called Asia is, before the eruption, already cool in winter. Now the winters are colder and longer, and the summers, when they come, do not warm enough to push the snow back to where it should be. Glaciers, which had been advancing slowly for thousands of years already, advance faster. Forests that had grown for 1,000 summers begin to die in single seasons. The boundary between the forest and the steppe moves south. The boundary between the steppe and the desert moves south too. Picture a stand of pine on a Siberian hillside. In the year before the eruption, the trees are old. Some of them are 500 years old. They have stood through long winters and short summers and the occasional dry decade. They are tall, and their needles are dark, and the bears that den under them have done so for as many bear generations as there have been humans living anywhere nearby. Now picture the same hillside, 4 years after the eruption. The pines on the upper slope are dead, their needles are brown, their bark is loose. The understory is full of the bones of small mammals who could not find food. The bears have moved south, looking for something to eat, and most of the bears are dead too. The trees themselves have not yet fallen. They will. In another decade, the whole hillside will be a grey graveyard of standing wood, and the wind will go through it with a sound that the hillside has not made in 1,000 years. That kind of thing happens, in the cold years, in many places. The full extent of the damage is hard to map at this distance. Pollen records show forest contraction. Sediment records show river instability. Faunal assemblages show local extinctions in some valleys. The planet absorbs the blow unevenly. Some ecosystems break and never quite come back. Others bend and recover. The thing about a 4-degree global cooling is that it is never 4 degrees in any one place. In some places it is 1. In other places it is 12. The averages hide whole worlds. Climate scientists in your century, working with computer models that no person on the African coast could imagine, have tried very hard to put numbers on this. The early estimates, from the 1990s, were terrifying. Some of them suggested global cooling of 15 degrees Celsius. That would have ended most of the world that humans depended on. Later models, much more careful, with much better physics, have softened the estimate. The current best guess is somewhere between 3.5 and 5 degrees of global average cooling, sustained for several years. That sounds gentler, but it is not gentle at all. 3.5 degrees is the difference between a world with reliable harvests and a world with crop failures. 5 degrees is the difference between a forest and a tundra in a place that is just on the edge of being one or the other. The numbers also depend hugely on where you stand. In the interior of Asia, summer temperatures might have dropped by 12 degrees in some years. In the southern hemisphere, in the coastal pockets of southern Africa, the local cooling was much less. It might have been only a degree or 2. That difference is the whole story of why we are still here. The places where humans were thickest on the ground were also, by sheer geography, the places where the cold did the least damage. The high northern latitudes, where the winter was unbearable, had no humans to bear it. The coastal south, where humans were, had a warmer ocean acting as a giant thermal cushion. We lived because we lived in the right places, almost by accident. Still, the African band notices the change. They do not have a word for it. They have words for hunger and for cold and for a season that does not behave the way it should. They have words for a hunt that goes wrong and for a child that gets sick and for an elder that dies. They put those words together and they describe the years that follow without ever needing to know that a volcano has erupted. It was not the ash that almost killed them. It was the silence after. The dawn chorus is a thing humans have always known without naming. The rolling wave of birdsong that begins before sunrise and crests as the first light touches the canopy. Robins, thrushes, weavers, doves, all of them in their species-specific hour. It is a sound that has been the soundtrack of a great deal of human history. The people on the African coast woke up to a version of it. The people in the Jwalapuram Valley woke up to a version of it. In the years after Toba, in many places, the chorus thinned. Some species kept singing on schedule. Others did not. Some mornings were quieter than they had ever been. The people who woke up to those mornings did not have a word for what was missing. They felt it anyway. They felt it the way you would feel it. The world is supposed to begin with sound, and on some mornings, the sound did not come. The ice cores tell us about the silence. The ice cores are exactly what they sound like. Long cylindrical samples, drilled out of the deep ice in Greenland and Antarctica, layered like the rings of a tree. Each layer is a year. The deeper you go, the older the year. Trapped in each layer is a tiny sample of the atmosphere as it was when that snow fell. Researchers in your century read these layers. They look for sulfate. Sulfate in ice means a volcano. The bigger the volcano, the bigger the sulfate spike. In the layer that corresponds to roughly 74,000 years ago, in both Greenland and Antarctica, the sulfate spike is enormous. It is one of the largest of the last 250,000 years of the ice record. It is a clean signal. It is the unmistakable footprint of Toba. It sits between two events that geologists call Dansgaard Oeschger events 19 and 20. It tells us, with a precision that would have astonished Stanley Ambrose when he first proposed all this in 1998, that a single eruption put a global mark on the planet's atmosphere, and that the mark lasted long enough to be preserved in ice that has been buried for nearly 75,000 years. The ice cores also tell us something humbler. The cooling that happened around Toba was not entirely caused by Toba. The world was already, before the eruption, slipping into a colder phase. The transition from a warmer interglacial-like period into a colder glacial-like period was already underway. Toba did not start it. Toba pushed it. Toba probably accelerated it, possibly by weakening the ocean currents that move warm water up out of the tropics. The world was on a downhill slope. Toba was a hand in the back. But for the people in the African shelter, the distinction does not matter. They cannot feel the difference between a slow cooling and a sudden cooling. They feel the cooling. They feel the failed harvests. They feel the children who are coughing more than they used to. They feel the elders who do not survive the winter that should have been mild. They feel the slow shrinking of the band. Some bands thin to nothing in these years. We know this because the genetic record knows it. We will get there. For now, on the coast, the people endure. They get smarter. In the small daily ways that people get smarter when they need to. They walk farther for shellfish. They fish in harder weather. They take their silkreed out from under the fire and they shape it more carefully than before. They are inventing, without realizing it, the toolkit that will let humans walk into the harshest landscapes on Earth and make a living there. They are inventing the future of the species. They are doing it because they have no other choice. The fire pops. A small ember lifts and dies. The child against the older woman's leg has slept through everything. The man who watches the sky has not spoken since the haze first appeared. Weeks ago, he still watches. The stars are dimmer. He has stopped trying to read the season from them. He reads it from the wind now, and from the way the antelope are walking, and from the color of the sea in the morning. He is adapting. They are all adapting. The species is adapting in tiny private ways, in tens of thousands of small bands, on 3 continents, all without anyone saying the word adaptation. Now, we have to talk about the bottleneck. The bottleneck is the heart of the story you have heard. It is the part that says we almost vanished. It is the part that says we were down to 2,000 people. It is true that this happened in some form. It is true that every human alive today carries the genetic signature of a population that, somewhere in this stretch of deep time, became very small. The argument is about why. Here is what the evidence holds, and then the argument comes after. There is a thing called mitochondrial DNA. It lives inside the small parts of your cells that make energy. It is passed down only through the mother. Your mother gave you hers. Her mother gave her hers. Your daughter, if you have one, will pass yours on. Your son will not. This makes mitochondrial DNA a kind of unbroken female line, traceable backwards through history through mothers only. When researchers compare the mitochondrial DNA of every person alive today, they find something very strange. All non-African human mitochondrial lineages, every single one, descend from a single African branch called L3. They can date the moment that L3 first appeared by counting the small mutations that have accumulated in it since. The number they get, with confidence intervals around it, is roughly 70,000 years ago. Soares and colleagues in 2011 did the careful work to pin this down. The middle of their estimate is right on top of the Toba event. The bounds run from about 79,000 to about 59,000 years ago. There is also a thing called the Y chromosome. The Y chromosome is passed from father to son. It is the male equivalent of mitochondrial DNA, traceable through unbroken male lines. When researchers look at the Y chromosome of every man alive today, they find another single ancestral branch called CT. CT diverged from its parent, the BT haplogroup, somewhere between 69,000 and 71,000 years ago. The dates land in roughly the same window as L3. Two completely independent genetic lines, a maternal one and a paternal one, both narrow to a single common origin in the same patch of deep time. When you find that kind of double signal, you have to take it seriously. It is very hard to get a coincidence like that without something real underneath it. Something happened around 70,000 years ago that funneled the ancestry of all later humans through a small population. The signal is unmistakable. The estimate of how small that population was, in genetic terms, is between 2,000 and 10,000 breeding individuals. The technical name for that figure is effective population size. It is not the same as the literal number of people walking around. The literal number was probably larger. Effective population size is the number of breeding individuals whose genes actually got passed down. People who never reproduced do not count. People whose lines died out 2 generations later do not count. The effective population size, in the strict mathematical sense, is what the genes remember. So the real walking around number, around 70,000 years ago, may have been somewhat higher. It may have been in the tens of thousands across the whole species. But the genetic narrowing is real, and it is severe, and it has fingerprinted every later human on Earth. There is also a wider context to keep in mind. Other large mammals show similar bottlenecks in roughly the same window. Cheetahs, in particular, have famously low genetic diversity, and their bottleneck dates to the late Pleistocene too. Asian elephants, some big cats. The cold transitions of the late Pleistocene were rough for big-bodied mammals everywhere. Not every species made it. Some species survived only as small, isolated populations that later expanded again. We are one of those species. We are a survivor in a small club of survivors, and the small club is itself the legacy of a hard age. You should sit with that number, 2,000. The lower end is the population of a small modern town. 10,000 is a single neighborhood in a city. The upper bound, the most generous figure anyone takes seriously, is fewer people than fit into a sports stadium. Every human being you have ever met, or read about, or seen on a screen, is descended from a group of people who could have all stood in one field together and seen each other. Imagine, just for a quiet minute, that field. The grass is dry, the sun is low, there are old people and young people and infants in slings. There are perhaps 100 fires going at the edges of the gathering. There are perhaps 400 dogs, who do not yet know they are becoming dogs, sniffing at the perimeter. There are several hundred separate languages spoken in this single crowd, each a little different, most mutually intelligible to their neighbors and not to the next one over. There are arguments, there are flirtations, there are children chasing other children, there are old people sitting and watching and remembering. Every face in this crowd will leave a lineage. Every face is someone's great 1,000 times great-grandparent. None of them know they are about to become the seed of a species that will, in time, count in billions. They are just there, in the dust, alive on a particular afternoon. That is not a literal scene. It never happened, exactly that way, in one place. The people who together made the founding population were spread across thousands of kilometers and many generations, but the genetic effect is the same. They were as small as that crowd. They could have, in some impossible moment, all heard each other shout. And from that crowd descend you, the voice in your ear, the people who built the room you are sleeping in, the people who built the planet you woke up to this morning. You are downstream of that field. This is the part that makes the story feel almost mythic. It is not mythic. It is mathematical. The way you measure it is by counting the genetic diversity in the modern population, comparing it to the diversity you would expect from a much larger ancient population, and then asking how small the ancient population had to have been to leave the diversity that exists. The maths is unforgiving. The answer keeps coming back small. We are, in a real and quantifiable sense, the descendants of a village. Stanley Ambrose, in 1998, was the first person to put all of this into a single proposal. He took the Toba date. He took the genetic coalescence dates. He put them next to each other and said, in effect, this is too neat to be an accident. He proposed the Toba catastrophe hypothesis. The volcano caused the bottleneck. The volcanic winter starved the species down to a tiny refuge in tropical Africa. We crawled out of that refuge, lucky, sparse, and slowly repopulated the world. Lynn Jord and Henry Harpending, working from the genetic side, gave him the population numbers he needed. Michael Rampino, the volcanologist, gave him the climate. The story was elegant, and it lined up across disciplines, and for a long time it was treated as the working consensus. The story is also, in its strongest form, almost certainly wrong. This is where the argument starts, and this is where the night gets interesting, because the new story, the messier story, is in some ways more remarkable than the old one. Because the new story is not about a species that nearly died. The new story is about a species that, in some places, did not flinch. The first place to break the simple story was in India. The Jwalapuram River Valley sits in the modern state of Andhra Pradesh, in southern India. It is hot, dry country today, full of rocky outcrops and thin scrub. 74,000 years ago, it was a little wetter, a little cooler, and full of forest. It was also directly in the path of the Toba ash plume. The ash that settled there was not a thin layer. It was meters thick in places. It blanketed the valley floor. Anything that breathed it was in serious trouble. Anything that drank from rivers that ran milky with it was in trouble. The valley should, by every reasonable expectation of the catastrophe theory, have emptied of human life. In the early 2000s, the archaeologist Michael Petraglia and his team began excavating a site in that valley called Jwalapuram Locality 9. They dug down through the layers. They found something quietly astonishing. They found human-made stone tools below the Toba ash. They also found human-made stone tools above the Toba ash. The ash itself sat as a clean grey horizon between the two, a perfect natural bookmark, and the tools were the same techniques, the same materials, the same flaking patterns. The hominins of the Jwalapuram Valley made a particular kind of Middle Paleolithic tool before the eruption, and they kept making the same kind of tool after. There was no break in the cultural record. There was no archaeological hiatus. There was nothing to suggest that the ashfall ended their world. Petraglia published this in Science in 2007. He used a careful word: continuity. The lithic record showed continuity across the Toba event. People had been here. People had stayed here. People had eaten the ash, breathed the ash, washed in water clouded by the ash, and they had kept making the same tools by the same fires the same way. They had buried their dead, presumably, the same way. They had passed knowledge from parent to child the same way. The ash was a slow grey snow that fell, and then it stopped, and life went on, harder and stranger and dustier, but on. There has been a lot of arguing since 2007 about exactly which species made those tools. There are no human bones at Jwalapuram, only the tools. Some researchers think the makers were modern Homo sapiens, an early eastward dispersal that reached India before the eruption. Others think the makers were earlier hominin populations that had been in South Asia for a long time. The argument is real, but the argument is not about whether anyone survived. The argument is only about who, exactly, the survivors were. Someone survived. Someone walked the ash-grey valley and broke stone against stone and lit fires. The valley did not empty. Picture them, if you can. Picture the morning after the ash first fell. The forest is still there, but it is wearing a coat of grey now. The leaves on the lower branches are bowed under the weight of dust. The river is the colour of milk. The air tastes faintly of metal and something burnt. The sun, when it rises, is a pale disk behind the haze, and it casts a flat, dim light that seems to come from no particular direction. You step out of your shelter. The ground crunches under your bare feet, where it should have been soft loam. You cough. The dog at your side, an animal you have raised since it was a pup, paws at its own face and sneezes, and you do not laugh, because you cannot remember the last time you laughed. You do what people do. You shake the dust off your hides. You shake the dust off your stone tools. You shake it off your children. You walk down to the river, careful where you step, and you dip a leaf cup into the murky water and you taste it. It tastes wrong, but it does not kill you, so you bring some back. You boil it, you drink it, you eat what you have stored, you wait. By the second day, the falling has stopped. By the third, the dust is settling. By the fourth, you go out hunting. The deer you find are coughing too. They are slower than they should be. You bring one down with less effort than usual. There is, in this small, terrible window, a strange surplus. You eat well that night. You wonder if you should be enjoying it. The valley does not collapse. It changes. Over the months that follow, the smaller creatures of the forest floor decline. The plants that depended on a particular insect, that depended on a particular pollen, no longer set seed. Some species disappear from this stretch of land for good. Others move in from the edges. The forest, by the end of the second year, is thinner than it was. The river is clean again, but its course has shifted, because the ash dam upstream eventually broke. You and your band have learned new walks. You have learned where the new game trails are. You have learned which tubers can be dug from under the dust crust. You have learned which water is safe and which is not. You have buried 2 of your old people and 1 of your children, and you have not buried any more than that, and that is the news that the archaeologists, 8,000 generations later, will quietly call survival. The second place to break the simple story was in Africa itself. This is the more surprising blow, because Africa was supposed to be the refuge. It was supposed to be the one continent where humans rode the bottleneck out, sheltering in a tropical sliver while everywhere else collapsed. The implication of the catastrophe theory was that even Africa was hit hard, even Africa nearly emptied, and only a tiny band of survivors in some specific tropical pocket carried the species through. Then, in 2013, a researcher named Christine Lane and her colleagues did something extraordinary. They took sediment cores from the bottom of Lake Malawi in East Africa, more than 7,000 kilometres west of Sumatra. Lake Malawi is enormous and very deep. The sediment at the bottom of it has been quietly accumulating, layer by layer, for far longer than humans have been a species. The team sliced into those sediments. They looked for cryptotephra, which is the technical word for volcanic glass shards too small to see with the naked eye. They found toba glass, tiny hooks and shards of it, perfectly preserved, in a thin horizon dating exactly to the right window. This was a triumph of method. It was also, when they read the layers around it, a quiet shock. The sediments around the toba layer showed no major change. The pollen record was the same. The fish species were the same. The chemistry of the sediment was the same. The local cooling, calculable from oxygen isotopes in the sediment, was about 1.5 degrees Celsius. That is a real change, but it is not a catastrophe. It is the kind of cooling that happens in a bad decade, not a world-ending one. The volcanic winter in East Africa had been mild. Lane and her team published this in 2013. The implication was clear. The Toba volcanic winter, however severe it had been globally, was not severe in the part of Africa where most of humanity lived. The continent that was supposed to be the desperate last refuge had been, by the standards of the early catastrophe theory, almost untouched. There was no volcanic winter at Lake Malawi. There was a chillier decade. People living through it would have noticed it. They would not have been driven to extinction by it. You can hold that picture in your mind for a moment. Picture the lake as it was then. It was longer than it is now, and deeper in places, and its shores were thick with reeds. Hippos moved through the shallows in the evening. Crocodiles slept on the warm rocks. Fish were thick in the upper water in the season when the wind brought the deep water up. The people who lived around the lake fished from small reed boats. They smoked the catch over small fires. They walked between camps along well-worn paths. None of that stopped during the Toba year. The sky was a little dimmer for a while. The water was a fraction colder. A child born that year grew up taller than her mother by the time she was 15. The rest was the same. The lake kept the people kept the lake. This is the thing that makes the story difficult to summarize. Some places had it terrible, some places hardly noticed. Both things are true at once. Toba was the largest geological event in 2 million years, and it was also a small fact in the daily life of a lakeside fisherwoman in East Africa. The world is large enough to hold both versions of the same year. The third place to break the simple story was the coast at Pinnacle Point, where you started this story, on the southern tip of Africa. In 2018, a team led by the geoscientist Eugene Smith and the archaeologist Curtis Marian published in the journal Nature a study that should have rewritten the textbook. They had spent years at the site, excavating a rock shelter called PP5-6 and a nearby site called Vliesbaai, just up the coast. They knew from the long stratigraphy that humans had lived at Pinnacle Point for tens of thousands of years before and after the supposed eruption date. They wanted to know exactly how those humans had fared during the ashfall itself. The trouble was finding the ashfall. Pinnacle Point is 9,000 kilometres from Sumatra. There is no thick grey blanket here. The ash, by the time it had reached the South African coast, was a microscopic dusting. To find it, the team needed to do exactly what Lane had done at Lake Malawi, but harder, because the sediment at PP5-6 is much messier, and the cryptotephra is much rarer. They sieved sample after sample. They examined the dust under powerful microscopes. They looked for the tiny, distinctive hook-shaped glass shards that form when a gas bubble in molten magma freezes mid-burst. They found them. They found enough of them. The chemistry of the shards matched Toba and only Toba. The stratigraphic position fixed the time of arrival. They had, For the first time at any African coastal archaeological site, an absolutely precise time marker for the eruption, accurate not to centuries but to weeks. They knew exactly which layer had been laid down during the ashfall. And the layer was full of people doing fine. Tools, hearths, heat-treated silkcrete, shellfish remains, hundreds of thousands of artifacts. The site, far from showing the kind of collapse the catastrophe theory predicted, showed the opposite. The behaviors got, if anything, more sophisticated across the eruption window. The use of marine resources got more intense. The lithic technology got more refined. The people of Pinnacle Point did not just survive the Toba event, they flourished through it. Curtis Marianne, when he wrote about this, used careful language. He did not say Toba had no impact. He said that, for at least one population of fully modern humans living in a coastal ecosystem with a marine buffer, the Toba event was a hardship that the population was already equipped to handle. The ocean kept giving them protein, the silkcrete kept giving them tools, the sky was darker for a few years. The shellfish were not, and in one of the most extraordinary lines in the published paper, the authors observed that the people at Pinnacle Point appeared to have weathered Toba so smoothly that the eruption was almost invisible in their archaeological record. Sit with that for a beat. The largest volcanic event of the last 2 million years left in the cave where some of the most resilient humans on the planet were living. Almost no archaeological mark. They cooked the same shellfish. They napped the same silkcrete. They lit the same fires. They slept under the same overhang. You can walk into PP5-6 today, and you can see the layers stacked up on each other like pages in a book. And the page where the world was supposed to be ending reads almost the same as the page before it and the page after it. That is what skill in a hard environment looks like. It looks, from the outside, like nothing happened. The lesson here is not that Toba was harmless. The lesson is that Toba was not equally felt. There were places, in the higher latitudes and in continental interiors and in the marginal landscapes between forest and steppe, where the cold years were brutal and the population thinned. There were also places on the coasts and in the tropics and around large bodies of water where the cold years were mild and the population held. The species, scattered across all of these places at once, did not experience a single global catastrophe. It experienced a patchwork of regional hardships. Some patches went dark. Some patches stayed bright. The bright patches held the seed. So now we have a problem. We have a genuine genetic bottleneck, dated to the right window. We have a real and enormous volcanic eruption, dated to the right window. And we have hard physical evidence that, in at least 3 of the places we can actually look at, the populations did not collapse the way the simple theory predicted. Jwalapuram persisted. Lake Malawi was barely affected. Pinnacle Point thrived. The catastrophe was real. The bottleneck was real. The link between them, the elegant single-core story, has come apart. What do you do in science when an elegant theory fails its evidence? You do not pretend the evidence is not there. You go back to the data and you ask harder questions. You ask whether the bottleneck was really a single global event at all. You ask whether it might have been a slower process with multiple causes. You ask whether the apparent narrowing of human ancestry around 70,000 years ago might be the genetic signature of a different process altogether. And the new answer that has emerged slowly over the last 15 years is yes, probably yes. The bottleneck, most likely, was not an extinction event. The bottleneck, most likely, was a migration. Think about what happens when a small group of people leaves a large population to settle a new territory. They take with them only a fraction of the genetic diversity of the population they came from. Their descendants, 10,000 years later, will look genetically as if they descended from a much smaller ancestral pool, because they did. The technical term is a founder effect. It is what happens to islands. It is what happens to remote valleys. It is what happens, on a much grander scale, when a few small bands of humans cross out of one continent into another. Around 70,000 years ago, give or take a few thousand years, a small group of humans walked or sailed out of Africa. The route is debated. Some went north through the Sinai. Some, more likely, crossed the narrow Bab el-Mandeb Strait between Africa and Arabia, maybe in the dry low water periods, maybe by simple boat. The crossing was not a big migration. It was, by best estimates, a few hundred people, a few thousand at the most. They were the seeds of every non-African human alive today. Every European, every Asian, every Australian Aboriginal whose ancestors walked across to Sahul, every American indigenous person whose ancestors crossed Beringia, every person whose family tree, however far back you trace it, leaves Africa at all of them descend from that one small band. That band would, in itself, have produced exactly the genetic signal we measure now. They were a founder population. They carried only a slice of the African genetic diversity. Their descendants, expanding into Eurasia and beyond, inherited only that slice. The slice we measure today, the slice that gives us coalescence dates of L3 around 70,000 years and CT around 70,000 years, is the slice that crossed the strait. Inside Africa, meanwhile, the populations that stayed behind kept their full diversity. This is exactly what we see today. African populations carry more genetic variation than all the rest of the world combined. They are not the descendants of a bottleneck. They are the descendants of the people who never left. The bottleneck signal is concentrated in the people who did leave, because the bottleneck was the leaving itself. That story, the founder effect story, does not need Toba at all. The eruption could have happened. The volcanic winter could have happened. They would have been hardships, and they would have killed some people in some regions, and they would have shifted some climates. But the genetic narrowing of all non-African humans does not require a global catastrophe. It only requires a small founding group. And we know from the archaeological record that a small founding group is exactly what made the journey. There is more to the picture, of course. There are other contributors. The transition from the warmer marine isotope stage 5 into the colder stage 4 was already happening. Climate was already getting harsher across the northern hemisphere, before Toba and after. The colder climate would have squeezed populations in marginal environments. It would have killed some bands and isolated others. Toba may have nudged some of those squeezes. There were probably regional bottlenecks all over the place, in ways that genetic analysis alone cannot resolve. The simple single cause story has been replaced not by another simple story but by a messier and more honest one. There were many small narrowings. There were many small recoveries. There was a great migration. The deep past was, as the deep past usually is, more complicated than a headline can carry. But the bones of the story you grew up with are still there. We were small. We were close to gone, in the sense that any small population is close to gone. We were lucky, in the way that any species that survives an unstable period in deep time is lucky. The volcanic winter was real, even if it did not do what we used to think it did. The bottleneck was real, even if it had several causes. We are the descendants of survivors, even if the survivors did not all live in the same valley. You can let go of the catastrophe story without losing what made it move you. The fact that we are here is still extraordinary. The fact that you are listening to a voice in the dark, in a warm bed, on a continent your ancestors did not reach for tens of thousands of years, is still extraordinary. The thread that runs from the African coast to your bedroom is still very thin in places and very strong in others, and it has not snapped in 70,000 years. That is the only thing the bottleneck has ever really been about. Not how close we came to going, the fact that we did not go. There are other bottlenecks in our story too, by the way. The genetic record carries traces of several. Some of them are older than Toba. Some of them are younger. Some of them are regional, affecting only the ancestors of one population and not another. We were always a small species in a large world, and we were always vulnerable, and we always passed through narrow points and emerged on the other side. The Toba bottleneck is the famous one because it is the most dramatic. It is not the only one your ancestors walked through. It is one of many. Each of them required someone to wake up the next morning and keep going. Each of them ended because someone did. Lie back into that. The fire is still burning on the African coast, 74,000 years ago. The man who watches the sky has stopped watching the sky. He watches his children. The older woman is asleep now. The child against her leg is asleep too. The mussels in the coals are cool. The shelter is warm. The night is long, and we have hours yet. Let us go further back, just for a few minutes, to make the scale of this real for you. Let us go to deep time. Let us pull the camera up and away from the coast, until the coast is a thin, pale line, and the band of people is invisible, and the fire is one small point of light in a darkness that covers the whole side of a planet. Time runs differently when you stop thinking in human lifetimes. A human lifetime is 60 or 70 years. A century is a long time. 1,000 years feels almost mythological. 30,000 years feels biblical. 100,000 years feels like the edge of comprehension. But these numbers are nothing in the deep history of the Earth. The Earth is 4.5 billion years old. Multicellular life has been around for somewhere over 600 million years. Mammals as a recognizable group are over 200 million years old. Primates are about 65 million. Apes are about 25. The line that became us split from the line that became chimpanzees about 6 or 7 million years ago. And in the last 7 million years, our ancestors have been small, scattered, and very, very vulnerable. The deep past of our line is mostly a story of near misses. The earliest hominins were not numerous. They lived in patchy habitats. They were prey for big cats. They had small ranges. Many of them disappeared. We share the planet now with no other hominin species, but for most of the last few million years there were several at any given time, and none of them lived forever. There were Australopithecines, there were Paranthropines, there were various early Homo lineages, of which we are only one. The fossil record is full of them. Most of the cousins are gone. Even within our own species, the survival rate has been unsteady. Anatomically, modern humans have been around for somewhere between 200,000 and 300,000 years. For most of that time, we were one population among many. We coexisted with Neanderthals in Europe and the Near East. We coexisted with Denisovans in Central and Eastern Asia. We coexisted, possibly, with a smaller form of Homo on the island of Flores and another small form on Luzon. We may have coexisted with archaic populations in Africa whose names we do not even have yet. only their genetic ghosts in some living African genomes. We were not, for most of our own existence, the only humans on Earth. The fact that we are the only ones now is itself a strange and recent condition. Think, for a slow moment, about all the cousins. Think about the Neanderthals in the cold parts of Europe, with their heavy bones and their broad chests and their deep-set eyes. They were not lesser, they made tools. They cared for their sick, they buried their dead, they had culture, they had, almost certainly, language. They lived alongside our line for tens of thousands of years, sometimes peacefully, sometimes not, sometimes intermarrying, often sharing landscapes. And then, slowly, they were gone. The reasons are still argued over. Climate, competition, disease, bad luck, probably some of all of those. The point is that they were here, and now they are not, except in the small fraction of Neanderthal DNA that lives quietly in many modern non-African genomes. They did not vanish. They were absorbed. Think about the Denisovans. We did not even know they existed until 2010, when geneticists looked at a small finger bone from a Siberian cave and realized the DNA in it did not match anything they had ever seen. The Denisovans had been there. They had been there for a long time. They had spread across Central and Eastern Asia, all the way down into the islands of Southeast Asia. Modern Papuans and Aboriginal Australians carry significant Denisovan ancestry. We do not have a face for them. We have only a finger bone, a tooth, a jaw, and a great cloud of genetic material distributed across living Asian populations. They were here. They are gone. They are absorbed too. The Toba moment happened toward the end of one of the harder stretches of that long story. The marine isotope stage 4 cold that bracketed it ran for maybe 10,000 years. That cold pressed down on populations everywhere. It pressed on the Neanderthals, who were, in that period, also small in number and barely hanging on in the colder parts of Europe. It pressed on the archaic humans of Central Asia. It pressed on us, and in the middle of that pressing, the volcano went off. And in the middle of that pressing, our ancestors started moving. The migration out of Africa was not a triumphant march. It was a slow oozing made by small bands at the edges of our range, in the places where the African population met its own borders. A band would push north. A band would push east. Most of those bands, almost certainly, did not make it. Their lines died out. The ones that did make it were the ones who crossed enough water, or enough desert, or enough mountain to find a new place where they could feed themselves and their children. They were the founder population whose descendants you and I share. What did they have? They had each other, mostly. They had stone tools that had been refined over 500,000 years of slow improvement. They had fire. They had clothing. They had language, almost certainly fully modern language, with grammar and tense, and a way of describing the past. They had stories. They had songs. They had ways of holding their dead in their minds, which is a quiet but world-changing kind of cognition. They had the long, slow inheritance of every living thing in their line that had not died yet. You can think of language, for a moment, as their greatest tool. Not the stone blades, not the heat-treated silkcrete. Language. A grandmother in the band could tell a child something the child had never seen, and the child would learn it, and the child could pass that knowledge on, decades later, to a grandchild she would never meet. Knowledge, in any other animal, dies with the animal. In humans, knowledge survives the body. A whole encyclopedia of where to find food and which plants are poisonous and how to read a sky and how to tend a fire could be carried, weightless, in the head of every adult, and renewed in every conversation, and refined every season. That is the technology that mattered most. They walked out of Africa carrying nothing but each other and what they could remember. It was enough. You can also think about what they did not have. They did not have horses. The horse would not be tamed for another 66,000 years. They did not have wheels. They did not have walls. They did not have rooms. They did not have privacy in any sense you would recognize. They slept against each other, on hides, in shelters that were never quite warm enough or quite dry enough. They were sick in ways your century has forgotten. Their teeth wore down by their 30s. Their joints hurt. Their children sometimes did not survive their first winter. They were, by every measurable standard, materially poorer than anyone listening to this voice tonight. And they were also, in ways that have not changed at all in 70,000 years, exactly like you. They did not have writing. They did not have metal. They did not have agriculture. Those things were tens of thousands of years away. They did not have a sense that we can tell that they were on the edge of becoming the dominant species on a small blue planet. They had no idea. They were just trying to find food and shelter through a hard season that did not seem to want to end. And here is the strange and quiet thing. The same species that sat by your fire on the southern coast of Africa, and the same species whose ash-grey hands were striking flint in the Jwalapuram Valley, and the same species whose tiny founding bands were edging out of Africa for the first time, that species is the same species you are. There has been no major biological change between then and now. You are not a more evolved version of those people. You are the same animal. If a child from that fire on the African coast had been picked up by an impossible time machine and dropped into a modern hospital nursery, that child would have grown up indistinguishable from any other child. They would have learned the local language. They would have gone to school. They would have used phones. They would have argued with their parents. They would have fallen in love. They would have become a person of your time. The wiring is identical. The sky above their fire and the sky above your bed are also, in their way, the same sky. The stars have moved a little. The constellations look slightly different now from how they looked then. But the river of light, the Milky Way, is the same river. The dust between the stars is the same dust. If you could go outside on a clear night somewhere far from cities, you could look up at almost the same view they looked at before the haze came down. You can put yourself, for a moment, under their sky, the stars they could not see. During the long dim years of the volcanic winter are the stars that came back. We do not know exactly when the haze cleared. It probably faded over 5 to 10 years, with the heaviest dimming in the first 2 or 3. By the time the older woman in the shelter had outlived the worst of it, the man who watched the sky was probably already old. He had watched the stars dim and then, slowly, brighten. He had passed his knowledge to his children, who passed it to theirs. The constellation that signaled the change of season was visible again. The hunters could read the sky again. The world had not ended. The world had merely been quiet for a while, the way long winters are quiet, and now the long winter was easing. A few thousand years later, the descendants of those bands were leaving the continent. Some of them headed north and east, along the southern edge of Asia. Some of them, much later, would push into the cold parts of Eurasia and meet the Neanderthals and have children with them. Some of them, much later still, would build boats and reach Australia. Some of them would cross frozen land bridges into the Americas. By 20,000 years ago, our species was on every continent except Antarctica. By 10,000, we had begun to plant seeds and tend animals. By 5,000, we had cities. by 2000, empires. By 200 years ago, machines. By now, you, in your bed, somewhere on the surface of that same planet, listening to a voice that has crossed thousands of kilometers of air and wire to reach you in the dark. The pace of that arc is hard to feel from inside a single human lifetime. Try to feel it anyway. For roughly 65,000 years, after the small bands left Africa, almost nothing changed in the way humans lived. Stone tools got slowly better. Clothing got slowly better. The control of fire got more refined. People learned to make rope. People learned to make bows. People learned to fish with hooks. None of these changes happened in a single year. None of them happened in a single century. The slow accumulation of small improvements, passed from teacher to learner across generations, is what built the toolkit your civilization eventually inherited. Then, somewhere around 12,000 years ago, something different started happening. People in a few places began to keep certain plants and certain animals close to their camps. Wheat in the Levant, rice in southern China, potatoes in the Andes, goats in the Zagros Mountains, cattle in northeast Africa. The change was not sudden. It took thousands of years to ripen, but the moment it took, it stopped being possible to live the old way without paying for it. Settled people had babies more often. Settled people stored grain. Settled people fought wars over the storage. Settled people invented writing to keep track of the storage. Settled people built temples and kings and laws, and most of the rest of the world that came after. Almost everything you know as civilization is downstream of a few wheat fields. But none of that is what your body is made for. Your body is still the body of the people on the African coast. Your body wants to walk a few miles every day. Your body wants to sleep when it is dark and wake when it is light. Your body wants to eat what is in season. Your body wants to be near a small group of familiar people. The fact that you, instead, sit in chairs and stare at screens and eat food that crossed an ocean and lie awake in a bedroom alone is a recent and slightly weird arrangement. It works. We have made it work. It is, by historical standards, a pretty comfortable arrangement, but it is not what the body was tuned for. The body was tuned for the fire on the African coast. That is why you find yourself, sometimes, soothed by the sound of a fire. That is why you find yourself drawn to the dark of an open sky. That is why a voice in the night, telling you a slow story, can make you so much more sleepy than the same words on a page. That long arc starts on the coast at Pinnacle Point. It starts at Jwalapuram. It starts at Lake Malawi. It starts at every fire that did not go out during the long, dim years. The branches of the family tree that lead from those fires to your bed are too many and too tangled to draw, but they are unbroken. There is no missing link. There is no chasm where the ancestors are not. There is only an enormously long, enormously slow chain of mothers and fathers, almost all of them anonymous, almost all of them illiterate, almost all of them dead, long before any of their descendants would think to wonder about them. Each of them lived long enough to have at least one child, who lived long enough to have at least one child of their own. That is the only fact that connects you to them. It is the only fact that needs to. The L3 mitochondrial haplogroup that you may carry, if you have a non-African maternal line, is the inheritance from one woman who lived in Eastern Africa about 70,000 years ago. Her name is gone, her face is gone, her language is gone. She had a daughter who survived. That daughter had a daughter who survived. Down through every generation since, an unbroken line of mothers carried her mitochondria forward. It rests in your cells now. It is making energy in your body as you lie in the dark and listen to this. Every breath you take is, in a sense, a service performed by her tiny ancient cellular machinery, which has not failed in 70,000 years. If you carry the CT haplogroup on your Y chromosome, the same is true of one man, somewhere near the same place, around the same time. He had a son who survived. That son had a son. Down through every generation, an unbroken line of fathers carried his Y chromosome forward. It rests in you now. He is, in a literal genetic sense, the great-grandfather of every non-African man alive on Earth. Not in any one of his named descendants would you ever find a record that admitted him. He has no monument. He has no obituary. His name was probably one syllable in a language none of us speaks. He lived. He died. We are still here. The strange thing about the deep past is how present it is. Your body is made of parts that were made by people whose names are unrecoverable. The hand that lies on your blanket has fingers shaped by selection pressures from the African coast. The way you sleep on your side, with one knee up, is the same way the older woman in the shelter slept, all those millennia ago. The way you breathe slows when you are calm. The way your heart slows when you are calm. The way the fire in front of you, even now in your imagination, makes you sleepier rather than more alert. All of that is inherited. All of that comes through them. Your fear of the dark is theirs too, and so is your comfort with it. Watch yourself for a moment. You are lying still. You are listening to a voice. You are aware, somewhere in the back of your mind, of the room around you. You are not entirely relaxed yet. There is a small, alert thing in your body that knows the night is the night, and the night is when predators move, and the night is when bad things have always happened to careless humans. That little alert thing has been on duty in your line for hundreds of thousands of years. It kept the older woman in the shelter alert enough to keep the children inside. It kept the man with the silver hair watching the horizon when other people slept. It is keeping you, in your bed, just slightly aware that there might be something at the edge of your hearing, even though there is not. But there is also a counterpart to that. There is a deep, deep willingness to let go when the conditions are right. When the body is warm and the room is quiet and the stomach is satisfied and the people around you are asleep, the alert thing relaxes. It hands over. It says, in the language bodies speak, that the night is safe and you can go. That release is also 70,000 years old. The older woman in the shelter felt it when the child against her leg fell asleep. Her own body softened. Her shoulders dropped. Her jaw unclenched. The fire was steady. The man was watching. The night was safe. She let go. You are doing the same thing now. You may not feel it yet. It is happening in tiny increments. The shoulders, the jaw, the hands, the hips, the breath. None of it loud, none of it sudden, none of it requiring any decision from you at all. It is the inheritance of every quiet bedtime that has ever happened on this planet, and it is moving through you exactly the way it moved through them. You came into a world they helped make. They walked into a world they did not understand. They carried the species through a time that almost ate it, and then they curled up by their fires in their small bands on coasts and in valleys and slept. They slept exactly the way you are about to sleep. Their hearts beat exactly the way yours beats. Their breathing slowed in exactly the same way. The dark was the same dark. The need for rest was the same need. And now, very slowly, we come back to the coast, to the shelter at Pinnacle Point, to the small fire that is still burning, after everything we have walked through in the same long night. The haze is thinning. It has been thinning for years. The man who watches the sky is much older now than when we met him. His hair has gone silver. He still tilts his head back, sometimes, on clear nights, and he still reads the stars. He does it more slowly now. The constellation he uses to read the season is back. The little dim ones have come back too. He is teaching his grandchildren which one means what. He is doing it in the same low voice his grandfather used with him 60 years ago, before the sky changed. The older woman is gone. She did not survive the worst year. She is buried in the floor of a different shelter, further along the coast, with a piece of red ochre placed on her chest by someone who loved her. The child who used to lean against her leg is grown. That child has children of their own. They sit by the fire now, in the same place, and they tell some of the same stories. The names in the stories have shifted. The shape of the stories has not. The mussels are still on the rocks. The silkreed still goes under the embers. The ocean still works at the cliffs. The wind is warmer this year than it was last year, and warmer than the year before that. The cold is letting go. Tonight the sky is fully clear. The river of stars is back. The man tilts his head and looks at it for a long time and does not speak. Some of his grandchildren, in time, will leave. Not yet, maybe not in his lifetime, but soon. Their children, or their children's children, will pack what they can carry and walk north along the coast. Some of those walkers will keep going. Some of them will turn east. Some of them will cross water. Some of them will reach a place where the strait between Africa and Arabia is narrow, and they will cross it in tiny groups of perhaps a few hundred, and they will become the seed of every non-African human who will ever live. They do not know this. They will not know it. They will only know that the coast keeps going, and they keep walking. Behind them, on the southern shore, other people will stay. They will keep their fires burning. They will keep eating shellfish and hunting antelope and treating silkreed under the embers. Their descendants will become some of the modern peoples of southern Africa, and other African ancestries will branch off and grow elsewhere on the continent. The ones who stayed will remain the largest, most genetically diverse, most deeply rooted population of humans on the planet. The ones who left will, by sheer geographic accident, become almost everyone else. Both groups, the leavers and the stayers, will be the inheritance of this fire on this beach. Both groups will have the same memory of a few hard years when the sky was wrong. Both groups will, eventually, forget. The memory will dim and become a story, and the story will dim and become a song, and the song will dim and become nothing. And the only record left will be the one written into the cells of their descendants, which will not be readable for another 70,000 years. You are reading it now. You are reading it without trying. Every cell in your body is the document that survived. Every breath you take is the next sentence in it. The fire is low now. There are only embers left. The man with the silver hair has lain down on his hide. His grandchildren are already asleep. The night is moving on. There are perhaps 2 hours until dawn. The Indian Ocean is doing what it has always done. The river of stars is doing what it has always done. The same wind that lifted the haze still moves over the cliffs above the shelter. The same constellations that came back are watching. You are warm. You are safe. The room around you is steady. The bed beneath you is solid. The blanket on top of you is soft. The breath in your chest is slow. The night is long. We have all of it. Listen for a moment to the small sound your body makes when it begins to let go. The slight loosening of the shoulders, the slight unclenching of the jaw, the slight softening of the back. You did not have to ask for any of it. It is doing itself. It has been doing itself in human bodies for hundreds of thousands of years. It did itself in the bodies of the people on the southern coast of Africa when their sky first cleared. It did itself in the bodies of the small bands that crossed the strait into Arabia. It did itself in the body of every mother and every father who carried your line through every dark year between then and now. Your pillow is soft, your blankets are warm, the ground beneath you is solid and still, the sky above you is steady, there is no ash in your sky, there is no haze on your stars. Whatever the world is doing tonight, your bed is its own small country, and that country is at peace. You do not have to do anything. You have already done it. You arrived. You are here. Somewhere on a coast in Africa, in a time you cannot reach, a fire is going out for the night. Somewhere in your bedroom, a light is already off, or about to be. The same animal lies down in both places. The same breath slows, the same eyes close, the same long quiet begins. The fire on the African coast has gone out by now. In the story you have been listening to, the embers cooled hours ago. The man with the silver hair is asleep. The grandchildren are asleep. The wind off the Indian Ocean is still moving over the cliffs. The stars are still there. The constellation that signals the change of season is rising slowly over the eastern horizon, the way it always has, the way it will when you wake up tomorrow on a different continent, in a different century. Your room is dark, your breath is slow, the voice in your ear is almost done. There is nothing more you have to do tonight. The story has been told, the thread has been traced. You have walked from a fire 74,000 years ago to a bed in your century, and the line between those two things has not broken once, and it will not break tonight, and it will not break tomorrow, and you can let go of holding it. The line holds itself. It always has. Sleep well. The night is long. The stars came back. Rest now.